So I'll be recording tonight. I'm going to start it in a couple of minutes. And I've been putting them up there. I've been able to get more than one at a time up there, which is probably nice. But there is a limit to how many I can stick up there in the files. So we still have, for chapter 8, we have 3 more sections to do. We're not going to do anything new tonight. We have one more integration method to learn, a partial fraction decomposition. I'll give you a little example of that before we leave tonight. And there's 2 sections after that. But what we're going to do tonight, so the last 3 classes, so we have last 3 subjects, so we have by parts and the trig integrals and the trig sub and all that kind of stuff. It builds up kind of quickly. So tonight, we're going to go over any kind of homework problems you want. Just talk a little bit about some stuff. And then, so you'll have the next 5 days, long time till Tuesday, to sort of keep working at those, and you'll have a chance to figure it out. Because Tuesday to Thursday is not a lot of time to absorb new stuff. And I know I'm not the only course that you're taking. So we got any, start off, we got any homework questions anybody wants to see? Doesn't have to be from just the trig subs. It can be from anything. Anybody got anything?
Did you go over number 23 from the homework last night?
Number 23, yep. Pull that up here. Number 23. 23, okay. Here's number 23. I think that's it, right? Oh, 4, there's a 4 here. That the one, Michaela?
Yes.
Okay.
I just have a question. Wait, sorry. Just like if depending on which one, you know how you said you could either make it like the side or the bottom of the triangle? Value? Like depending on which one you make it, would it like make your answer like result in a different answer? Would you get like the same exact answer?
So in fact, we'll look at this both ways. When you're loading up the triangle, the only thing you don't have a choice about is a hypotenuse, right?
Mm-hmm.
Whether you call this side A and this side B or this A, you have both options on there. One of them might be easier than the other one, or they might be equally the same. But when you switch them, you will get different looking answers. The answers will be equivalent, but different looking.
Okay.
Yeah.
Thank you.
So a lot of times in this book, sometimes when you look at the answers in the back of the book, it'll be a form of an answer and you're thinking, how did they ever get that? So sometimes he puts equivalent answers that are the same but look different just to kind of make you think a little bit.
Okay, I was just making sure. Thank you.
That was a good question. All right, now, first of all, I'm going to reduce this a little bit to make our lives easier. There's a common factor of 4 here. So I can factor out the 4 and then pull the 4, whoops, wait a minute, sorry. I meant to start the recording, but I didn't, hang on. Okay, so common factor of 4, so I can take the 4 out, and then I can pull it out of the square root where it becomes a 2. So there, that'll make our life a little bit easier, right? Oh, wait a minute, sorry, this is a 2. No, wait, 4. There. So that just makes the arithmetic part a little bit better. In general, if you can, and not even calculus I'm talking about, and not even math I'm talking about, if you have a problem to solve anywhere in life, if you can do something first to reduce it down to make it simpler, you should do that, right? So there. So now we'll do this. Now, we don't have a choice on the hypotenuse. This is the negative sign. That means this is the hypotenuse square. So the hypotenuse is 2. Now, Kayla, to get to your question, one of the other sides is an x. So we could put the x here, and we can put this here. Or you can do it this way. You can do it either way. So in this case, x over 2 is the cosine of the angle. This over 2 is the sine of the angle. If we do this one, x over 2 becomes the sine of the angle, and this over 2 becomes the cosine. In fact, if you kind of rotate this right triangle around, you'll get the same thing. So both of those are legitimate and legal. And for this particular problem, one of those isn't going to be any harder or easier than the other one. So one of those, your answer is going to end up having cosines in it, and the other one, your answer is going to have like a negative sign in it or something like that. So since Michaela, since you asked this question, which one of these did you use, top or bottom?
I did the top.
Okay. So as I mentioned, I found out often in this book from teaching from it for a long time. So you have x and the square root thing. That's a little more complicated looking. I found out from his problem that if you put the complicated one up there, it generally can work out easier. But in this case, it's the same. So we'll use the one that you did. All right. There is no x to the first in this problem. We only have an x squared, but we still need an expression for x to calculate the dx. So adjacent over hypotenuse is the cosine of the angle. So 2 times the cosine of that angle is equal to x. And what always goes with a cosine in calculus? Always?
Sine.
And so opposite over hypotenuse is the sine. There we go. So now this integral becomes, the 2 is a constant, it just sits there. And we have 2 sine theta. This is this, right? This is the trig part. This is the sub part. But we can't just put d theta down there. We have to calculate it. And that's why we need an expression that just has an x in it. So the derivative of x is the derivative of x. And over here, the derivative over here is -2 sine theta d theta. And this comes down here. And now we're down to that. Okay, good so far?
Yes.
Okay, now I'm going to clean this up a little bit. -2 times 2 times 2 is -8. And that leaves me with sine times sine, which is sine squared theta d theta. So our original integral hasn't been changed. It's just been transformed into a different language, the language of x into the language of theta. So now, forget all of this stuff. Here's a new integral to do. So this is like the stuff from section 8.3, I guess. All we have is a sine. We have a sine squared. So that generally means we need to use the power reducing formula. So we get 1 sinus minus, and we get cosine of 2 theta all over 2 d theta. Hang on, Brandon's coming in here. I'm joining up. And there we go, he's in. Okay. Now we integrate this. I'm going to take this away. And just a reminder, I'm recording this. I know I have to erase stuff a bunch. All right, -8 divided by 2, -4. That leaves us with 1 minus cosine of 2 theta d theta. So now we integrate. the integral of 1 with respect to theta is theta. This is a little tiny u sub here. So this becomes, so u is equal to 2 theta, and 1/2 du is equal to d theta. So what we get over here is minus the integral of cosine of u du. So we get -4 theta. The integral of negative cosine is negative sine. So we get, I forgot the 1/2 out here. So this becomes -1/2 the sine of 2 theta and then plus c. So that answer, that answer is correct. That is a correct answer. So any questions on that part yet? So Michaela, we're not in a classroom, so calling you out won't make you embarrassed or anything, but I'm just curious, at what part were you unsure about what you were doing?
I got to there, and then when I tried to plug back in for like X's, I got a different answer than the book, and I just wasn't sure like how they were the same, you know?
Oh, yeah. So because of this 2 theta, the answer is going to look awkward.
Yeah.
Yeah. So I'm going to probably give you an answer that's not in the book. And this may sound strange, but in this course, the answer is not really important. Does that make sense?
Yeah.
Not the answer. It's the methodology to get there. So let's keep going here. So you got up to here just fine?
Yes.
Yeah, of course you did. Of course you did. All right. No, yeah. You're going to really like discrete math, by the way.
I hope.
Oh, no, you will. You can, Brandon and Nicole are in your class, and we just went through discrete class with them, and they'll tell you how much fun it is. Okay. All right, so now we got to put things back. So here we have a theta. Another good reason to have an x. So I'm going to put the 2 back over here. So the cosine of theta is equal to x over 2. If we solve this for theta, we get theta is equal to the arc cosine of x over 2, right? Or, well, no, I can't do that yet, but I'm going to put this over here. Or I could solve this for theta, and I could say that theta is the arc sine of all of that. So if we had labeled the triangle the other way, we would have wound up with this would have been the cosine and this would have been the sine. So that's where the different answers come up. So I'm going to use this one. So we get -4 arc cosine of x over 2. And then we get minus 1/2 the sine of 2 times the arc cosine of x over 2 plus c. And for me, that's the answer. And that's not what you saw in the back of the book, is it?
No.
No. You can, if you think back to your trig or your pre-calc days and trig days, when you did arc sine of the arc sine, there's ways to mess around with this and make it look something a little less intimidating.
Yeah, I was wondering how I'd find a way to like simplify that. I was like, I don't know.
Well, I don't want to use time tonight to do that, right? But do you still have a pre-calculus book?
I think so.
Well, so advice to all of you, by the way, wherever you're going after Calc 2, whether it's something engineering or biology or chemistry or anything, get yourselves a pre-calculus book. You can find them online for $5. You know, they might be 2 or 3 editions back or something. You can find them for $5 or $10. In all seriousness, get a pre-calc book and never get rid of it. That's the ultimate reference book for anything involving all the trig stuff. Like, how do you do sine of the arc cosine? And there's chapters about that. Exponentials, logarithms, sigma notation, sequences and series, all the fundamental algebra stuff is in there. So that's my recommendation. So Michaela, I'll send out something about this weekend because I think I have a lot of free time.
Okay, thank you.
Is it okay if I just kind of like hop over that for tonight?
Yeah, that's fine.
Yeah. So check your pre-calc book somewhere. It shows you how to do like the cosine of the arc sine and all that kind of stuff.
All right, I'll look into it. Thank you.
It's not difficult, but it's the kind of thing you kind of like forget afterwards.
Yeah.
Sort of like a nasty tasting medicine. You just don't even want to think about it, right? Yeah, it's not really so bad. Okay. So that answer's fine for me. That was a good one to ask. Who else has a question? Anybody? Anybody got a question? All right.
49, the trigonometric integral.
49 from the section before?
49 from this section, but the second half of the question.
Oh, okay.
The part about the trigonometry.
All right, I'm getting there. 49. Oh, that was one about the thinking. That was a thinking problem, right?
Yeah.
49. The second part.
Not the use substitution part, the part with the
Yep.
triangle plotting and stuff.
Yep.
Thank you.
So lots of times, so I'm not doing anything new tonight because, and Rebecca, I see that, number 27. I'm not doing anything new tonight because I think you need time to like put all this together that we've done from chapter 8. So you have these 5 days. What I will send out for homework later tonight, who am I kidding? It's not gonna be later tonight, tomorrow. I'm gonna send you out a sheet with like 15 or 16 integrals on it. But I'm not gonna tell you the methods. So you're gonna have to figure out for each one of those, the method or methods you can use to solve each one of them based on everything we've done. And there might be 1 or 2 in there that can't be done, right? So one of the hard parts about chapter 8 is looking at an integral when you're not told what method to use and figure out, how am I supposed to do this? I mean, at this point, a hard question in calculus right now is this integral easy or hard? That can be a hard question to answer, right? So I'm just going to send out a bunch of integrals and we'll be going over those on Tuesday. So number 49, oh crap, forgot what it was already. All right. So there's the problem. Oh, there we go. Now, this can be done as a u substitution, not an obvious u substitution, though. So this would be our u, and the derivative would essentially give us an x to the first. And this is x to the first times x to the first. So you would do the u substitution that way. And then the problem tells you to memorize this a little bit better. Oh, Rebecca, oh, hang on. Oh, but part B of 49 does, oh no, Rebecca, John asked me to do part B. Is that right, John?
Oh, sorry. I wrote it down in B on my homework just to make sure I didn't get messed up with the 2 parts of the problem. But no, it's just 49A, the second part of A.
Oh, so the
sorry
homework.
About that.
So the homework said just do 49A.
Yeah.
Oh, okay, that's good because 49B doesn't look like fun at all, does it? But no. You can give a shot at that. So thank you, Rebecca, for helping me and John figure out what we were really doing. So yeah, so this is part A. So it wants us to do this 2 different ways, all right? So first method. First method is u substitution, which is the easier method. In fact, if you've been practicing U subs a lot, I'll bet some of you can actually do that in your head without even looking at it, right? So U is the bottom. U is the complicated, not the bottom. U is, so here's a piece, here's a piece. The U is the more complicated of the two. So U is equal to x squared plus 9. Du is equal to 2x dx. There is no 2 in this problem, so this 2 has to come over, and that gives us this. Okay, so now in this integral, the bottom is U, and 1/2 du is x dx. And there's our integral, and this is 1/2 the ln of U, but U is this. And there's the integral by U substitution. And how would you know if you're right? The back of your book fell off. You don't have the answers anymore. How do you know if you're right?
Sorry. You just find the derivative.
Yeah, no, I wasn't talking just to you. Everybody.
Sorry.
Yeah, if you do this, yeah, that's okay. If you do this derivative, you will get this. Okay, that was U substitution. That was the easy way to do that problem. Now it says do it by trig substitution. Okay, the second method is trig sub. Okay, there's no square root here, and that doesn't matter. We have something plus something. That means we can use trig sub. Because this is a positive sign, so because this is a positive sign, because it's a positive sign, this whole thing is the hypotenuse squared because of this. So this comes over here like this. Right? And then, so back to Michaela's thought, so x to the first is one of the other sides, and the square root of 9, 3 is one of the other sides. We can put x here, we can put x here, we can put 3 here, we can put 3 here. It can be anything we want. So let's see here. I'm going to put, I'm just going to do it this way. Right, now we pull it off. Opposite over adjacent is tangent. And hypotenuse over adjacent is secant. So now, but we don't have a square root of x squared plus 9 over here. We have x squared plus 9. So that will give us, that will be 9 secant squared theta is equal to x squared plus 9. So our integral becomes, on the bottom, we get this. On the top, we have x, which is this. So far, so good?
Mm-hmm.
But we're missing a piece. That's not an integral. That's a yucky looking fraction with a funny squiggly s in front of it. That's not an integral yet until we put the differential here. And we can't just write d theta, we have to calculate it. And we use this to calculate it. Derivative of x is dx. The derivative of 3 tangent is 3 secant squared theta d theta. So that comes over here. There. Okay.
I got that, and then I integrated.
Well, can't integrate quite yet.
Oh yeah, you have to multiply everything first.
Well, we gotta clean it all up, right? Make it simple. So 3 times 3 is 3 times 3 is 9. 9 divided by 9 is 1, so they're gone. This secant squared cancels out that secant squared. And we're left with just tangent theta d theta. Now we can integrate. So what's the integral of tangent?
Negative log natural, the cosine of theta.
Yep. Whoops, sorry, there's a negative in front. Like you said, negative ln cosine theta plus c. Well, I'm not going to use a c for constant. I'm going to use a k because we got a c for cosine in there, right? Okay. And that answer is correct. But our answer came to us with x's in it, so it's only appropriate to hand it back with x's. That's more of a stylistic thing. So cosine theta, now we still have our triangle. So negative ln cosine is adjacent over hypotenuse. So we get 3 over the square root of x squared plus 9 plus c. Oh, sorry, plus k, not that it matters. And there we go. Well, that's one form of the answer. The problem we did just a minute ago by u substitution is an equivalent answer to that, but looks very different. If we had switched the x and the 3 around, we would have had secant being the x and tangent being this, and we would have gotten yet a correct answer that's equivalent, roughly the same as all the other ones. Mm-hmm. It's a little confusing, right?
Yeah. I actually got the answer, but the fact that they looked different kind of threw me off. Yeah. So I thought I did something wrong.
No, you did something different. So again, a lot of chapter 8, it's really self-confidence, right? And you're all new at this, so you're not really self-confident. The confidence isn't there yet. And that just comes with practice, practice, practice. All good questions to ask. Anybody got anything else? Oh, Rebecca, I'm sorry, number 27, right there in front of me, and I forgot all about that. Nothing personal. So let's do number 27. The book. You probably think it's crazy anybody would want to be a math major, huh? Well, this isn't really math. This is kind of like arithmetic. Okay, number 27, integral 1 over. We really got to invest in some more lights in here. Oh, x square root of 4x squared plus 9 dx. There we go. All right. So, put you on the spot a little bit here remotely, Rebecca. What method did you try, or did you just think, not quite sure? Remember, in this book, just because we're in a section called trig sub doesn't mean every problem will be trig sub. But did you try trig sub first? Oh, yeah. Yeah. Yes. Okay. So on the last one, that's not a problem of knowledge or understanding. That's more a problem of sort of not reading the signs, right? Yeah, and so that's not a problem you'll do again. Now, so, but remember, so here, forget the x, forget the square root. We've got one thing plus another. So when you're looking at a general integral, if you have an x in the integral that shows up in 2 different places, and one of the exponents is exactly 1 less than the other, That's a sign to maybe try a U substitution. Now in here, we can't try a U substitution. This is an x squared, but this is not an x to the first. Why is that not an x to the first? Looks like an x to the first, right? But it's not an x to the first. Why not?
Because it's in the denominator.
Ah, Jordan, nice. This is actually in the denominator. If I put that x up here, it'd be x to the -1, and then we can't use U substitution. It's just part of the fun of chapter 8. Nice one, Jordan. All right, so we go right over here. Because this is a plus sign, we have no choice. This whole thing is the hypotenuse. And then I'm going to put the x over here and the 3 down here. Oh, sorry. 2x. How come that's a 2x? Right, this is 2x squared, and the square root of 9 is 3. Okay, so here we go. No, we're not going to drop it. Right, over here, I'm going to have an expression that says x equals something, and that will replace that x. Right, so when you do trig sub, you're not replacing everything here. We're just building a triangle separate from all of this. And then we go and put stuff back. Okay, so opposite over adjacent is tangent. So we get 3/2 tangent theta is equal to x, and that's what's going to go here. And then hypotenuse over adjacent is secant. So we get 3 secant theta is equal to that. So now our integral looks like this. We have 3/2 tangent theta, that's this, times 3 secant theta, the one up there. So this piece goes here, this piece goes here. We'll take care of the constants in a minute. And then we have to calculate our dx. It's kind of messy, doesn't it? So derivative of x is the derivative of x, and then we get 3/2 secant squared theta d theta. So that comes over here. We get 3/2 secant squared theta d theta. Oh, and now the reward. A whole bunch of stuff is going to cancel out. Let me pause there for a second. Anybody got any questions about anything?
Why is that secant squared theta on top?
Well,
it's replacing dx. Okay.
yeah, secant squared, that actually is here,
Okay.
but I moved the secant squared up, that's all.
Okay.
You okay with that?
I think so.
So there is a 1 up here, but the dx, this dx is actually on top.
Mm-hmm.
Some textbooks, and it drives me crazy, some textbooks will actually put the dx up there. And I don't know, it's like fingernails on a blackboard to me when they do that. The dx ought to be out in the back where it belongs to me. Right?
Professor
So-
Gordon, you should make
What?
I think you should make a textbook.
In all my, yeah, no, that's all right. With all the arithmetic mistakes I make, you guys catch me with, oh, you drop that negative sign. Oh, wait, that x is an x cubed, not an x squared. Are you kidding? I'd have to hire all of you to proofread it. All right. Now, a whole bunch of stuff cancels out. Whoa. This 3/2 cancels with that 3/2. And this secant cancels one of those secants. So we can rewrite this more simply as that 3 stays, so there's a 1/3 out in front, and that leaves us with, what does that leave us with? 1 over tangent theta d theta. So it all reduces down to that. Looks a whole lot better already. Oh, and there's a secant above. Thank you. See, I'm not writing a textbook at all. I forgot that secant's still there. So we get secant theta. There we go, d theta. Okay. Looks better already. Now, looking at that, I think, geez, I don't know. So there's no always do this rule, but I'm going to change everything into sines and cosines. Secant, the secant is 1 over the cosine. Tangent on the bottom, tangent is sine over cosine, but that tangent's on the bottom, so this becomes cosine over sine. Oh, and look at that. This is like a little nerdy reward for getting through all that stuff. Cosines cancel out. We get 1/3 sine of theta d theta. And that's a really easy looking integral. I'm recording this, remember?
Wait, isn't that sign on bottom?
Oh, yeah. Oh, geez, see? See, as soon as you mention textbook, now I'm making all kinds of mistakes. So that's 1 over the sine d theta, and that becomes 1/3 cosecant d theta. There, that's the integral that we're doing. And now you're thinking, I don't know what the integral of cosecant is, because whoever runs into these, you have all of those in your book on the front or the back cover, and in chapter 8 somewhere is a whole list of basic integrals. So anybody want to tell me what the cosecant is? Integral? Probably got an ln in it. Anybody happen to see that? 1/3 the ln of cosecant theta plus, cotangent theta. And I'm going to use k for a constant instead of a c. So is that correct? Anybody want to object to what I wrote there?
You need to move or change it back to x's.
I will, but is this correct? Don't trust me. I'm sorry, what, Rebecca? Oh. So if you ask me, if I don't teach Calc 2 for a year or two, and you say, quick, what's the integral of cosecant? I'm going to have to sort of like, wait a minute, let me think about this for a second, right? I'm in 20 or 30 years, when I can't even remember my own name, you ask me what the integral of cosine is, I'm going to tell you sine. But cosecants, cotangents, if I don't do them for a while, I got to think about them a little bit. Yeah, how about that? You know I'm right? Because it came up in the calc class earlier today. So I remember them once I start doing it. And now, yeah, so this answer is mathematically correct, but we're going to put it back in terms of x's. So cosecant is, so the sine is opposite over hypotenuse. The cosecant is the upside down sine, hypotenuse over here. So we get square root of x squared plus 9 over 2x. Cotangent, tangent is opposite over adjacent. Cotangent is adjacent over opposite, plus the same constant. And that answer is good enough for me. You could write this as one fraction because it's got the same denominator, but yeah, this is fine. Now, what would be kind of ugly, so what do I always recommend you do? Once you do an integral, what do I always suggest you do with your answer? Yeah, go ahead, do the derivative of that. You will get the same answer. That'd be a pretty good exercise. So if we were in class, if we had an in-class test, which, we don't, that's the kind of thing I would do as an extra credit. Do the derivative of that and confirm it's the integral of that. And that would be something you say, oh, good thing extra credit. I'm not doing that, right? But that'd be a good exercise for you. So I would suggest rewriting it as 1. And then maybe it wouldn't be so bad. So good question, Rebecca. Good question. What else we got? Anybody? Yeah. All right, we'll keep practicing. So I'm just going to show you a little bit, a trailer of coming attractions for Tuesday when we do something called partial fraction decomposition. Now, some of you I know have seen this in pre-calc. I know that some of you have seen this in pre-calc and have no memory of seeing it in pre-calc. And some of you have never seen this in pre-calc or anywhere. So it's going to look a little overwhelming. So I just want to, that's why I don't want to do anything new tonight. Once you get good at all this stuff. So partial, the one we're going to do on Tuesday, that's the last integration method. The last 2 topics we do in here are integration with a little bit of philosophical stuff thrown into it, where we integrate all the way to infinity. And we have to learn about something called L'Hopital's rule, which I know some of you have seen in Calc 1, but we'll go over that again. All right, so 3/7 plus 5/9. How do we add those fractions together? Ooh, we're doing like 5th grade math here. So how do we have to, what do we do to do that?
Common denominator.
Yep, we need a common denominator. 7 and 9 have nothing in common with each other. So the lowest common denominator, the laziest one, is just 7 times 9. So we get 27/63 plus 35/63, and that's equal to 62/63. I may have done that addition wrong. Did I do that right? Is the top 62? Yeah, I did that right, didn't I?
Yes.
Oh, yeah. Okay. So there's 2 fractions here. There's 2 parts. This is 2 parts. Fractions are 2 parts. And we compose those 2 parts into 1 part. In order to do the kind of integral we need to do on Tuesday, we have to go this way. We have to decompose a single object into 2 or more parts. And then we integrate each part separately. So that's the idea of what we're going to be doing with partial fraction decomposition. It sounds deliciously nerdy. So I'll give you a little example of how this works and do a real simple example for you. Now that denominator is this, and I factored it into here. None of the methods we use so far will work on that integral. Can't do trig sub because nothing's being squared. There's no algebra kind of thing we can do on here. So this is going to decompose. So this x times x plus 1, that is the LCD. That's the lowest common denominator. So in the denominator here, there are 2 separate factors, a factor of x and a factor of x plus 1. Both of those x's have exponent 1, so they are linear factors. So this is going to break down into two factors, two parts. We'll have one with an x on the bottom, and we will have one with an x plus 1 on the bottom, dx. If you add these, just like when we did this, when we added these two fractions together, because they have nothing in common, the common denominator is 63. 63 decomposes into two factors with nothing in common. So these two factors will decompose into here, right? What we need to do to finish this problem is figure out what the numerators are on the top. We don't know. So we're going to call this A and we're going to call this B. Now, A and B are constants. They're not always going to be constants, but for tonight they are. So constants are just numbers. So I can finish this integral. What's the integral of 1 over x? What's the integral of 1 over x? What has a derivative of 1 over x?
Natural log of x?
Yep, and this is a constant. So we get a times the ln of x. Over here, this plus 1 doesn't matter. It's an x to the first, so the integral of this is also an ln. There. That's what this integral is that. What we need to do is figure out what the A and B are to finish the problem. In the partial fraction section we're going to do on Tuesday, your answers are either going to be the ln of something or perhaps an arctangent of something. That's all that's going to happen. There's only two kinds of answers that are going to come out. So what we need to learn in the meantime is how to come up with the A and the B. I'm going to show you how to do that. Just going to look at this fraction. If we add these two fractions, if we compose this direction, this will be our common denominator. The top won't be a 1, though, unless we pick the exact right values for A and B. So now we're just going to do some algebra. And all of this is, your book explains the algebra part of this in front, but he does it in like one page, and he does it in a way that I think makes it much more confusing. This is why it's good to have a pre-calc book. So I have an equation. I can do whatever I want as long as I do it legally and equally to both sides. So we are going to multiply everything by the LCD. It's going to multiply the whole thing. When I multiply the LCD by this, these all cancel out and leave me with a 1. When I multiply this towards here, the x's cancel out and leave me with a times x plus 1. When I multiply all this times b, the x plus 1s cancel out and leave me with b times x. Just looking familiar to anybody? Anybody recognize maybe having done this in the past? Yeah. Okay, now we have one equation with two unknowns. Can't solve that by algebra here, but we can do something here. I'm going to do a shortcut method. I can pick any value for x that I want. We're just looking for the a's and the b's. So I'm going to let x equals 0. Right? And I'm going to put x equals 0 in here. There's no x here, so this stays 1. Then I get a times 0 plus 1 plus b times 0. Well, that just tells me that 1 is equal to a. That's the value of a, 1. By picking that value here, I made the b disappear, and that allowed me to find a. I went from an equation with 2 unknowns to an equation with 1 unknown. So what x value can I pick to make the a disappear?
1.
Not 1,
Oh, -1.
-1, yep. So now I'm gonna so a is equal to, whoops, sorry. So a is equal to 1. Oh, sorry. So a is equal to 1. And now I'm going to let x equal -1. There's no x here, so this stays 1. So we get a times -1 plus 1 plus b times -1. So that means 1 is equal to -b, and that means b is equal to -1. So b is equal to -1. So there's our A and B, and this is being recorded. We're going to do all this again on Tuesday. I'm just kind of letting you know what's coming. So our final answer here is, this is a 1, and our B is -1. So our final answer is the ln of x minus the ln of x plus 1 plus a constant. That is the integral of this, and this is an easy derivative to do. So you can check the answer on that one. So that's where we're heading on Tuesday. Totally different from everything else we've been doing, which is why I'm not doing it tonight other than to sort of show you where we're headed. So over the next few days, go back to the kind of integrals you did at the end of Calc 1, the basic ones and the basic U sub. Then we did by parts. We did trig integrals with sine to a power, cosine to a power, secant to a power, tangent, and we did the trig sub stuff. So start going over those again. Like I said, sometime tomorrow, maybe tonight, but I kind of highly doubt it. I'm just going to send you out a handout sheet, a homework sheet with like 15 or 16 integrals on it. And it'll be up to you to figure out which ones can be done. And maybe there will be 1 or 2 on there that actually can't be done. And you should say can't be done by any method I know or something like that. So anybody got any other questions about anything? Well, all right. So I'm going to stop the recording right now. And so I guess I'll see you on Tuesday. All right.
Thank you. Have a good weekend.
All right. Enjoy your weekend. It's supposed to be